Okay, ladies, welcome to our notes about sine and cosine, the graphs of sine and cosine 6.4. We'll do a little bit of the transformations found in 6.5 as well. Some things that you want to have available to you. You can have this video obviously up on your screen. On OneNote, there are several documents that you need. The Notes 6465 graphs, which we will just use the first two rows of today, and then the Notes 6.4 transformations, which we will complete as well. It would be a good idea also to look at, besides second semester videos where you found this, second semester applets, which is where both of the applets are that I'm going to use today. So for instance, to look at the graphs of sine and cosine, I'm going to go first to this 6.4 sine and cosine curves. You're welcome to watch how I do it in the video, pause the video, and then go back and try it on your own. I will also be using the 6.4 transformations today that is off of the Desmus website. So you're welcome to, at any point in time during these videos, stop and take a look at these on your own. So the first website I'm going to go to is the graphs of sine and cosine. Now there's nothing you need to actually write down at this point, just watch at what I'm doing. Now originally it did start at 1 radian. Remember, 1 radian is about 57 degrees. So it makes sense that that's what it looks like, but I backed it up to 0 radians. What this slider is going to do is work its way all the way around the circle, so through the 2 pi radians, and what we're going to take a look at first is the graph of sine. So for instance, at 1 radian, you see the graph of sine, which is represented by this red graph here, is about this high. So at 1 radian, you have, 0.6 radians, you have just a little over 1/2 for the sine or the y coordinate. As I keep going, there it is at 1.6 radians, that'd be about pi over 2. Notice that sine is 1. It's graphing the same coordinates over here. So along the x-axis on the graph, it's graphing the radians, and along the y-axis, it's graphing how large the sine value is. Now notice once I go past 90 degrees or pi over 2, the sine value starts going back down. So does the wave over here on this graph. Okay, then once I get to pi radians, it crosses over into the lower half of the unit circle. So what do you think it's going to do over here? It's going to go negative, but repeat the same pattern in terms of growing and then decreasing again as I go past the y-axis there. I'm going to try and stop as close as I can to 2 pi. No, 6.3 is about 6.28. So there is one full period of sine. So one repetition of this wave pattern. Notice that it will allow me to go past a little bit, and that pattern keeps going. And it's as far as I can go at this website, but the pattern will keep going on and on forever. And that would be true for the negative side as well, because keep in mind I could not only go counterclockwise, I could also go clockwise. So that wave pattern representing sine would continue on and on forever in both positive and negative x direction. I'm going to turn the sine off for a minute and take a look at cosine. So how do we think that's going to be different? Well, cosine measures the length in terms of x instead of in terms of y. So when I slide the slider, it's going to look very similar, but keep in mind we're paying attention now to the blue, the length of the blue, as opposed to the length of the red. So if I just go up a little bit, almost 1 radian or so, I noticed that my cosine, unlike sine, started out high because it started out having a full length of 1. And then as I move along the radians, cosine actually gets smaller as sine gets bigger. So it actually starts off by decreasing, and then once it hits pi over 2 or 90 degrees, it actually will go negative, because now we're talking about negative x's. So x now is on this side of the xy axis. So it's going to continue the same pattern, getting larger in the negatives. And then we'll see if we can stop it right about there. At pi radians, cosine is going to continue being negative, but it's going to start increasing in positivity, meaning getting less negative, getting closer and closer. At 3 pi over 2 radians, this is where it is going to cross over and be positive again, because once again we're talking about the x value. And right about there is where we would get 2 pi. So there is one period of the cosine function, one repetition of its wave pattern, but once again, notice that it would continue on and on forever as well as I kept going around the circle. And this would be true as well. If I could take that slider and go negative, it would repeat on the other side of the graph. Okay, so let's compare them both at the same time. Notice that the sine is going to be red, the cosine is blue as I move through the radians. They have the same wave pattern, but just based on whether you're looking at the x or the y coordinate, the wave has been shifted over or transformed over a little bit. Okay, let's take a look at what that would look like in our calculator. I'm going to graph sine of x, so sine button x. I'm going to make sure that I'm in radian mode. Anytime we graph this chapter, we'll be in radian mode. And I'm going to hit zoom 7, which is zoom trig. And there is my graph of my sine function. Okay, so on this one I can see both positive and negative. If I go to my window, I can tell that it is a little bit bigger than I would like. Let's change that to, instead of doing what it has it set, I'm going to set it between negative 2 pi and positive 2 pi. So I'll have that fixed in the notes here for us instead of going by what it had previously. The x scale is going by pi over 2. So just like the website's graph, the tick marks are going to be in half pies, and then the y's are fine. Now when I hit graph, there we go, that's a little more of what I was expecting. So I can tell, for instance, that it has x-intercepts at 0, and then this would be 1/2 pi, this would be 2/2 pi, or just pi, 3/2 pi, and 2 pi, likewise in the negative direction. Let's pull up the notes. Here is just how I have it fixed now, what I would recommend your graph to be set on in terms of the mode and the window. And what I would recommend you doing first is to go to that 6.4, 6.5 graphs of trigonometric functions page, and we're going to fill out, first of all, just the information for the graph of sine of x. So sine of x, we can tell, once again, based on how the unit circle is set up, that sine of x will have a domain between negative infinity and positive infinity, because you can keep going around in either the positive or negative angle direction. It would have a domain of all real numbers. So either all real numbers or between negative infinity and positive infinity. Make sure you use parentheses. The range, on the other hand, is a little more limited. So for instance, y will never be 5 or 10. It keeps going back and forth between -1 and +1 because that's the values that sine equals on the unit circle. So it can only be between -1 and +1. And because it can't actually equal those values, we'll use brackets. Okay. As far as symmetry, remember, even symmetry is where it would be folded across the y-axis, and odd symmetry would be if I turned it upside down. In this case, for sine, we do have the odd symmetry, so look at the graph on your calculator. If I flip it upside down, it does look exactly the same in terms of where it's crossing the axis, where it's waving up or waving down. Okay, so we would say this one has odd symmetry. Now this one is the period is the one function that we have not talked about in other graphs, and that is because it doesn't usually happen in parabolas or other polynomials. The period is, as I mentioned on the previous website, how long for one cycle of the function. So in order for our wave to go all the way up, all the way back down, and back to where it started, it takes 2 pi radians or 360 degrees. So for one iteration of the wave, it's 2 pi radians. And that's the one that's the newest of any of the other features. The y and x-intercept are exactly what it sounds like. So where does sine of x cross the y-axis? It would cross at the origin, so at y equals 0, or at 0, 0, however you prefer to write it. And then the x-intercept, it has an x-intercept at 0, or 0, 0. It also has an x-intercept at 2 pi over 2 and 4 pi over 2. Remember, I'm going by half pi's in both positive and negative. So that'd be reduced positive or negative pi and positive or negative 2 pi. Okay, so it occurs on both sides of the y-axis. Go ahead and pause the video here, graph cosine for yourself, and then see if you can fill in the features of cosine that occur from the graph that you can see on your calculator. Okay, I hope you've had a chance to take a look at the graph of cosine on your calculator. Here are the answers for cosine. Cosine will also have the same range and domain as sine. So even though the wave has been shifted over, it does go on and on towards positive and negative infinity in the x direction, but it only bounces between positive and negative 1 on the y. It has even instead of odd symmetry because I can fold it across the y-axis. It also has a period of 2 pi just like sine. In that one full wave, all the way down, all the way back up, takes 2 pi radians. The y-intercept is 1 for plane cosine. Notice that both of these will change if the graph has been shifted up or down or stretched vertically. So this is just based on plane sine, plane cosine. And then the x-intercepts that we can see, positive and negative pi over 2, so the first tick mark, positive and negative 3 pi over 2, the second tick mark on either side of the y-axis. And once again, just a brief clarification, the x-intercepts we're recording here are not the only x-intercepts, it's just the only ones that we can see on the graph between negative and positive 2 pi. So, for instance, you could describe the x-intercepts for sine being every multiple and other multiples of pi. And then for cosine, it would be other non-reducible half pi's. Okay, so 5 pi over 2, 7 pi over 2, the ones that would not reduce to be an even multiple of pi. Okay, for tonight's homework, the last thing I just wanted to mention is some of the questions in the first section are as simple as saying, what is the y-intercept of y equals cosine of x? So you can just get that directly from your chart or from the calculator. I wouldn't recommend memorizing the chart, just understanding how we got those answers from the chart would be beneficial in terms of answering questions like the homework. The ones that people have had trouble in the past with have been ones of like, where is sine of x equal to 1 at what x value? Okay, and all that means is at what value of the radian is sine at its peak. Okay, so where is sine, which just means where is it equaling positive 1. Okay, likewise, if I was asking negative 1, it would be these points. So you'd say it happens at positive pi over 2, at negative 3 pi over 2, because those are the two places where it would equal on the graph. Okay, hope this helps. You'll be looking for the second video for the transformation part of the notes.